So most of you know, I scripted this, so it may sound a little wooden, but I have to go very fast. When I say next, go to the next slide. My name is Steve Paget. I'm an architect and professor of architecture at the University of Kansas. The following is a very brief synopsis of 2 USGBC and AIA continuing education courses I offer: Water, Energy, Carbon, Nexus, and LEED, and Green Infrastructure and LEED. I've presented these multiple times to design professionals and community stakeholders. Next. The water, energy, carbon nexus must be seen in the context of the interaction of natural systems and artificial systems. No time to delve into it. Next. In the US, the single greatest use of water, freshwater withdrawals, is energy, and the single greatest use of energy, thermoelectric generated, is water systems. Next. Here we see the state of Kansas's electric generation and consequent CO2 emissions as of 2008. These emissions could fill over 4 million Goodyear blimps. Next. Kansas's thermoelectric generation use about 821,000 million gallons of water, or about 17.6 gallons per kilowatt hour. Next. Roughly 20% of all electrical power serves water systems and irrigation, and 39% of all freshwater withdrawals serve electrical power generation. The irrigation should be doubled, so it would be 40% if it's both parts of the electrical power. Anyway, next. 5 average single-family households use 1 million gallons of water per year. To offset the carbon footprint of this water consumption would take 108 trees. Next. The challenges posed by the water, energy, carbon nexus are, and we can see the slide here, and then they're exacerbated by number 5 and number 6. So energy-water relationship, energy equals carbon, water equals carbon, resources are overtaxed, the demand supply is unsustainable. And then we've got combined sewer systems, impervious landscape, heat island effect, pollution, and natural systems harmed, watersheds, air and water quality, and ecosystems at all scales. Next. But there are some ways to address these challenges as seen in the next CE course, Green Infrastructure and LEED. Next. And here are some principles to help address the water, energy, carbon nexus. Treat human waste as a resource, treat stormwater as a resource, engage in reuse and reclamation practices with water, and then use green infrastructure in addition to gray infrastructure in order to do what it said. I won't read the whole thing. And then use biomimicry techniques in order to restore the watershed. Next. Gray infrastructure challenges can be met by the use of green infrastructure. You can go back and look at the slides later if you want to get the detail. Next. And here are some examples of green infrastructure techniques: recessed planters, bioswales, constructed wetlands, permeable paving, and bump outs, curb bump outs. Next. And here's a section of Kansas City, Missouri, the Crossroads, has a large portion, 425 acres, of the city's combined sewer system, that is, that conveys both that area's sewage and stormwater in a single pipe. Next. And then here are the applications of green infrastructure techniques in order to address that volume of water or runoff. So the infiltration planters, the pocket parks, the green roofs, pervious pavement, bioswales, all intended to slow down and clean the water and potentially even get it to then go into groundwater. Next. The installation of green infrastructure techniques in the Crossroads would reduce the runoff by 60%. Next. Urban area without green infrastructure. Next. Urban area with green infrastructure. It also looks better, and it's very similar to the Crossroads and many other places. It's similar to Lawrence, for that matter, in terms of the number and density of development and so on. Next, LEED is the most accepted certification platform for sustainable design. A narrow footprint building design coupled with green infrastructure techniques address no fewer than 10 LEED credits. Remember, I'm showing this primarily to design professionals. Next, here's the Odom School of Ecology applying the same techniques. Next, these are its sustainable design features. Scan. Next, its proposed water cycle greatly reduces all the water, energy, carbon challenges of existing practices. The existing up and above, just a simple linear model of the diagram, and then the cyclical one that reduces the water use by 75% at the time of this kind of snapshot in the design process. Next, and the proposed energy cycle greatly reducing the water, energy, carbon challenges of existing practices. Next, and here are those same sustainable design components seen in section that you saw earlier. Okay, next. And here's the project's landscape as a partial restoration of the watershed functions, including a new riparian corridor. Next. One more example, the Omega Center houses a biologically based sewage treatment system, otherwise known as an eco-machine, that serves a community of up to thousands. Next, some of this building's features, and this is where these tanks that you see there in the cross section with water plants finishes the cleansing of the pollutants, or it's basically the human waste from the water before it is then sent on out to the nearest large body of water. It's a lake. And then there's some other components there. I won't talk about the building ones, but let's look at that. Okay, next. The landscape features better explain what it took in order to have an eco-machine functioning, along with some other things. First, the sewage goes to septic tanks. I'll skip over the other ones. It then goes to anaerobic tanks that are somewhere, I don't know if you can see my cursor, but anyway, that are down near these, yeah, right, down near the constructed wetlands, which is the second place it goes. And they're actually in tubes that are punctured. And then it's pumped back up to these aerated lagoons up here. And then it can go to the sand filter and then on out to the lake, or it can also be used partially for gray water use. Next. And here are some of the metrics leading that project to meet the requirements of both LEED Platinum and the Living Building Challenge, which requires that the project is net positive in terms of energy, and it is net positive in terms of water. Okay. Did I stay under 9 minutes? That was very quick.
You did, well done.
A lot more information and data and stuff. And, you know, I had engineers and architects in the first time I did it.
Yeah, Steve.
It also doesn't talk about the iterative process. Again, they're stakeholders. So yeah. I was doing secondary research in order to distill it down and use a lot of illustrations, diagramming, etc., in order to make that understandable for them.
Steve, let me ask a question. Who wants these kinds of buildings? Who are architects designing these buildings for, and how much money do those people have?
Yeah, well, currently the GSA, it's all of you. The GSA requires all of their new construction to meet or exceed LEED Gold standard.
Wow.
And now it has added Green Globe, so it has a second platform that you could also use. And they are the single largest entity building new construction and renting space. Their rented space, they won't go into any space that isn't at least LEED Silver. Wow. So that kind of gives you an idea right there, but there are plenty more too. LEED just exploded. I mean, it's being used a lot. Yep. And even entities such as the university here, at least they pay reference to it. They don't require certification, which, as far as I'm concerned, you must do. You know, if it ain't documented, it ain't. You know, and what's the other one? The other it's fight chaos, make lists. You know, if you don't measure it, you can't manage something that you don't measure. You know, et cetera. But yeah. Anyway, that's what that kind of certification by a third party does. Yeah. And it forces you to go through a lot of other steps. But a lot of architects are doing it, a lot of engineers, a lot of contractors are all now used to using it. A lot of manufacturers have changed what they make and how they deliver it and how they process it, how they source it. It's just exploded.
Yeah. Are you aware of any research about the growth of LEED and how it's become so important?
It's mostly self-reported, I think. I haven't seen any kind of other entity looking into it. There might be. I'd be interested to see it. But
if I find some, I'll let you know.
Is the parent organization.
Right.
You go to their website and you see this exploding graph. You know, numbers of projects per year. It's worldwide now. It's all over the place. Different countries have their own version of the platform, but yeah, because they vary it for their location.
Yeah, great. I think. Thank you so much, Steve. And it's really fascinating. And I know I'm going to be in touch with you. So.